Chapter 9, Section 5, Part 3. Adding and subtracting rational expressions. Again, we still have different denominators, and now we add on an extra layer of a little bit of extra work to do. We still have to make the denominators be the same by finding the least common denominator, which again is the product of the distinct factors, but we have more work to do because the denominators are going to need to be factored. All right, so here's our list on what to do. Now remember, when you have an assessment or a review for the assessment, these problems are all going to be mixed together, and so you're going to have to know what to do. You're going to have to recognize, are the denominators the same already? Are the denominators already in factored form that all I have to do is quickly build a least common denominator? And if they're not, if I've got like binomials and trinomials, I'm going to have to factor. All right, so you must factor each denominator completely. And then we're going to list the factors of the first denominator. You need them all. And then you add to the list any factors of the second denominator that do not appear in that first list. And then we form the product of each different factor from the list in step 3. This product is your least common denominator. All right, so let's take a look at example 1. I've got an x plus 6. Folks, I can't factor that anymore, but this is dots. Dots factors as x plus 6 times x minus 6 for this particular case of dots. My least common denominator. You need everything in the first denominator. That's x plus 6. Then I look at the next denominator. X plus 6 is already in there, but x minus 6 is not. That's distinct. That's different. And so my LCD is this product of these two distinct factors. All right, that's my LCD. Now, we're going to write the original problem. That's a subtraction sign. I'm going to write this in factored form. All right, now I have to decide. I have to make the denominators be the same. The common denominator is x plus 6 times x minus 6. This is only an x plus 6, so I need to multiply by quantity x minus 6 over itself. This already has them both, so that's just multiplied by 1 over 1. Nothing's going to change there. All right, so what do I have here? Well, 3 times quantity x minus 6. Subtract quantity 2x plus 12. You have to group it. All over now the one common denominator, x minus 6 times x plus 6. Remove grouping symbols. This is 3x, subtract 18, subtract 2x, subtract 12. All over x minus 6 times x plus 6. Combine like terms in the numerator. 3x subtract 2x is 1x. Negative 18 subtract 12 is negative 30. all over the one common denominator, x minus 6 times x plus 6. This is my final answer. I can't factor anything out of x minus 30. That would be a common factor to what's in the denominator. There are restrictions. X is not allowed to equal negative 6 or positive 6. And so then my domain, if I was interested in writing my domain, negative infinity to negative 6, in union with negative 6 to 6, in union with 6 to infinity. Okay, so if you have any questions on that, let me know. Why don't you pause the video and try number 2? All right, hopefully you pause the video and try this one on your own. Remember, practice by doing, that's how we learn best. All right, so least common denominator was this times this, x minus 5 times x plus 5. I set up the two original fractions and showed what I was multiplying by to make the denominators be the same. This turned out to be x plus 5 times itself, so I wrote it as x plus 5 quantity squared, subtract x minus 5 quantity squared. Now, you do have to square out these binomials, or FOIL. Okay, so when I FOIL, I get x squared plus 10x plus 25. Subtract the quantity of this trinomial. You have to group it, okay? It's subtract this thing squared. So it has to be grouped because you need to distribute the negative sign. Okay, so my like terms, well, here I'm going to expand this. I'm going to change the signs of everything. So it became x squared plus 10x plus 25, subtract x squared, add 10x, subtract 25. Notice x squared and negative x squared were opposites, so they're going to equal 0. I'm not dividing them out. I'm adding them and they become 0, right? 25 minus 25 is 0. What's left is 10x plus 10x, or 20x. Okay? 20x has nothing in common with x minus 5 and x plus 5 because those are quantities. So this is my final answer. The restrictions is part of the answer. Okay, you must list restrictions always, always, always. And if you're asked to give the domain would be written like this. Negative infinity to negative 5 in union with negative 5 to 5 in union with 5 to infinity. So if you have questions on that, please let me know. Okay, I can't help you unless you tell me you need help. All right, one more example on the back. It's maybe you would think it's a little bit longer. It's not so much longer, but there are 3 fractions now instead of 2. The process is still the same. If this is not prime in the denominator, then you have to factor it, okay? You have to remember to factor x squared minus y squared. That's dots. That's x plus y times x minus y. 2x minus 2y. Well, folks, there's a GCF here. 2 times the quantity x minus y. There's a GCF here. 2 times the quantity x plus y. Now, building my least common denominator, I need everything that's in the first denominator, which is x plus y times x minus y. I look at the next denominator. 2 is not in there yet. It's different, so I have to slip that in. X minus y is already in there. This 2 is already in there. This x plus y is already in there. This is my LCD. Okay, right here. All right, now I'm ready to set up by writing my original fractions. I'm going to leave some space after my equal sign because I know I'm going to have to multiply by something. So this is x over x plus y times x minus y plus 3 over 2 times quantity x minus y. I'm going to leave some space because I have to multiply by something, right? Okay, do that if you want to. And then it's subtract, so make sure you're writing the proper sign. 5 over 2 times x plus y times some fraction to get the denominators to be the same. Now, what do I have to multiply for to make this denominator be this? Well, that's 2, so 2 over 2. This has the 2 and the x minus y, so I need the x plus y over itself. This has the 2 and the x plus y, so I need the x minus y over itself. All right. Now I'm going to write one fraction bar with the common denominator. Right, because that times that is this, this times that is this, this times that is this. So I'm just going to write it one time. I have to take care of what's on the top. This is 2x. This is plus 3 times quantity x plus y. And this is negative 5 times quantity x minus y. The rest is just simplifying the top. So distribution property, right? That distributive property, I can't speak. 2x plus 3x plus 3y minus 5x plus 5y. All over common denominator. Combine like terms in the numerator. Linear terms, I've got 2x plus 3x is 5x minus 5x is no more x. Okay, so these are all going to equal 0. 3y plus 5y is 8y over 2 times quantity x plus y, x minus y. Can I simplify anything? Sure can. This is 8 times y. This is 2 times this times that. Multiplication and division are inverses. So the 8 becomes a 4 and the 2 becomes a 1. So numerator is 4y. Denominator is x plus y over x minus y. Restrictions. It's part of the answer. Okay, set it not equal to 0. X plus y cannot be 0. So x cannot equal negative y. And guess what? I'm going to set the other one. X minus y cannot equal 0. X cannot equal y. If I solve this, x plus y cannot equal 0. If I solved it for y this time, y cannot equal negative x. If I solve this one for y this time, x minus y cannot equal 0. Negative y cannot equal negative x. Divide by negative, y cannot equal x. So what do I got? These two really basically say the same thing, right? But we're going to write it as x and y because it's two variables. Two variables. X cannot equal, what can x equal? It can't equal negative y, and it can't equal y. What can't y equal? Well, y can't equal negative x, and y can't equal x. Okay, this is part of the answer. Again, because the x's and the y's aren't actual integer values, we're not going to write a domain for that one. Okay, so if you have any questions, please let me know. Let's see how you could do on the homework assignment. Remember, it's essential for you to check your answers. It's essential for you to get some help if you don't know or understand what you're doing. Because later, we're going to get into multiplying and dividing rational expressions. So let me know what questions you have. Have a great day.